Do you know what a neutron star is? Its terrifying nature might go far beyond your imagination, and it could completely change your understanding of the universe. First of all, the density of a neutron star is incredibly high. So high, in fact, that it's almost beyond comprehension. To put it simply, the Earth's radius is 7,245.2 kilometers. If you were to compress the Earth, without changing its mass, into a sphere with a radius of just 15 meters, only then would its density barely match that of a neutron star. In other words, a tiny piece of material just 1 cubic decimeter in size would have a staggering mass of several hundred million tons. It's truly unbelievable. It is reported that a typical neutron star has a radius of about 7 to 15 kilometers, yet despite being so small, its mass can reach up to 2.6 times that of the Sun. Can you imagine just how terrifying that density is? Secondly, the rotational speed of a neutron star is unbelievably fast. Recently, astronomers discovered a neutron star in the universe with an incredibly fast rotation. It spins 2,141 times per second, which means it takes only 0.00127 seconds to complete one rotation. Its rotational speed is about 1 billion times faster than that of the Earth. Can you imagine just how terrifying that rotational speed is? And the radiation from a neutron star is also incredibly terrifying. The total radiation energy of an ordinary neutron star is about 2.17 million times that of the Sun. At this point, do you feel like you have no concept of what that really means? Let me give you an example. If all the total energy from the radiation of an ordinary neutron star were converted into electricity, then the energy it emits in just 1 minute would be enough to power the Earth for tens of billions of years. At this point, you should have an idea of just how terrifying the primordial power inside this little guy is. It's practically a monstrous existence. So where exactly do neutron stars come from? According to scientists, a neutron star is actually the corpse of a star that has already died. Scientifically speaking, it is the product left behind after a star undergoes gravitational collapse and explodes at the end of its evolution. However, the condition for its formation is that the mass of the star must be between 20 and 55 times that of the Sun. So here's the question. Between a black hole and a neutron star, which do you think is more powerful?